Well, here are the questions. A few of those were worked out in class. The first one, as always, the diagrams are very important. So now, in this question, the torque is calculated about this end. So that means all distances are measured from this end. So when you look at FB, that creates a counterclockwise torque. This point. This has no torque because the distance is 0, and this creates a clockwise torque because it tries to turn it this way with respect to that point, and so does this one. So these two are clockwise, this is counterclockwise because it's trying to turn it the other way, and this one has no torque. Here, of course, we are using the idea that the total downward force is equal to the total upward force. Okay, and getting that. Remember that in part A, we are not considering the mass of the beam. Not considering. That's why it's not there. But in part B, it's considered, and that's the only difference. Well, that is where the pivot is. Once again, in 2, the total length given 75 kilograms at one end, 25 at the other. We have to find where the pivot is. Take it as X. That's the A part. The B part, you consider the mass of the beam. So in 3,
new message.
you have 3 children.
Shall I read it?
There are 3 children there. $35, $50. You're actually asked to find out where the third one must sit down. 2 are at the ends, and the third one we're assuming is seated here, so X distance away. Well, understand that in this case, again, sure, this is the pivot, and you see that this force creates a clockwise torque, so does this one, but this one creates a counterclockwise torque. So all you got to do is 50 times that distance is equal to 25 times this plus 35 times this. All distances measured from the pivot. This one was done in class, but here it is. The tension is resolved into Ft cos and Ft sin. The Ft cos components cancel out because you do resolve this into 2 and do the same on this side. Resolve this into 2 components. So you see that the horizontal components cancel each other, being equal and opposite, but the vertical components add up. So each one is Ft sine theta, and so you end up with 2 Ft sine theta, which is going to actually balance the weight acting down, which is mg. And from which you can calculate Ft. And the fifth question, now there are two supports, so there are two forces acting up. And what you try to do is, because there are two unknowns, we eliminate one by taking the torque exactly at the point where one is acting. Because when you do that, the torque due to Fa becomes 0. You see that? So now then you only have this creating a clockwise torque, which is 1.764 times 0.5, and the other is a counterclockwise torque. Look at that, counterclockwise torque given by Fb times the distance. Remember, we're taking it at this end, so you measure both distances from there, 1 and 2. This creates clockwise and this creates counterclockwise. And again, the sum of the forces is equal to the total down. So total upward force is equal to total downward force. You get both Fa and Fb. Number 6. Alright, calculate the friction. First, it's mu times mg. You get that's 14.1. Thus, I'm going to redraw the diagram. Okay, now let me explain these forces to you clearly. Label it first. Alright. Okay, so you're trying to move this obviously to the right side. You're trying to move the lamp to the right side, and that's why friction is acting in the opposite direction. Okay, and then this is the normal reaction there. And then you have the weight of this lamp acting vertically down, and you also have the force, the horizontal push that you're trying to apply to make it move. Now this is a particular case where the lamp must not topple over. So that means the force that you're applying has become equal to the frictional force, exactly equal. So this force of friction is equal to this. And that's what I'm writing now. So the force that you calculated for friction is the same. So too, the normal reaction is equal to the weight. So that means the forces, total forces down is equal to total forces up, and total force to the right is equal to total force to the left. That's always the case in statics, because the forces must cancel each other, and the torques must also cancel each other. That's the sum and substance of this chapter. So now that we know that, we got the forces, now we'll try to calculate the torque about this point as pivot. When you do that, you see that there is no torque due to Fn, nothing due to friction, because the distance from that point of both of these is 0. So the only torque that you're going to have is, this is going to create a clockwise torque, see, because it's trying to rotate it this way, clockwise. While if you look at this, the weight acting, carefully you look at it, you see that it's trying to rotate it counterclockwise. So it is the weight that is balancing the torque due to the force of the push. And what about the distances? When you take the torque of this, it's going to be F times X. And when you take, due to the weight of the lamp must be equal to this multiplied by the radius of the foot of the lamp. So obviously that has to be given, and I forgot to mention that, I forgot to give that in the question. So let's take the diameter as 20 centimeters, so that you get the radius as 10 centimeter, which is 0.1 meter. That's what I'm doing now. And when you do that, you get X as 0.5 meters. You cannot apply that force any more than a height of 0.5 meter. Number 7, piano kept 1/4 of the way. So here I'm considering that the total length of the beam that's not given is about 4 meters. So I mean, it's divided into 4 equal parts. So you have 1, 2, 3, and 4. Okay, that's the mass of the beam itself, and then the mass of the piano. Once again, we total upward force is equal to total downward force. And then you try to take the torques about one end. So take this as the pivot. So there will be no torque due to this. 140 and 320 create clockwise, and FB creates a counterclockwise. Multiply each force with the correct distance from the left end very carefully, and get that as 310 kilograms. But since you want the force, you just multiplied with 9.8. And then FA is 460 minus FB, from which you get FA in kilograms, and then change it into newtons. Unfortunately, the 8th question is the same as 5. I did not realize that when I made up the question set. So that's done. And number 9, it was worked out in class and also worked out in the quiz. So I'm not doing that again. Number 10, That's the equation for Young's modulus. Straight, direct substitution, you get the answer. 11. This is a tough nut to crack. Well, in the first part, it is similar to another question that we did. As you may recall, you see the ft cos theta is cancelling out, and 2ft sin theta becomes equal to the weight. So from that, we can find the tension. As before, find the tension. Alright, once you get that, this is the equation you're going to use for Young's modulus, but remember that you're asked to find the radius, so which means you have to find the area of cross section. So you get this. Now to know this, the Young's modulus would be given, although I did not mention it there, it would be given. But then you got the force, which is the tension. So, which means you have to find what this ratio is. So that's the plan. We just calculated the force. This is going to be given for aluminum. It is 70 GPa. And if we could get this, then we could surely calculate the area from which you could find the radius. So that's the next idea. How do you get this? For that, look at this figure carefully. You see that this point would have been exactly this if there was no stretching. A would have just gone to this point. So when you look at it carefully, you see that this is how much it has stretched. So that is your delta L, and your original length is this one. Just taking half will do because it's anyway a ratio. So from this triangle, using the angle given, you need to figure out an equation for the ratio, which I'm going to do. Well, AB by BD is cos theta. And BD can be split up as BC plus CD. And obviously CD is a change in length. So on the other side, now here, this is what we wrote just now from the other side. Distribute and get this ratio as 1 minus cos theta by theta if you watch carefully. Substitute the value of theta which is given and get the ratio. And then go back to the Young's modulus equation, make A the subject, and did you notice that it's actually the reciprocal of this, because we got this, and it's, so that's why I put 1 by point. Okay. So once that is obtained, you know that area of cross section is pi r squared, and calculate the radius from there. It's a lot to think about there and a lot of math, but you feel good once you understand it. Now the last one. Since it's given as a percentage, that's why you multiply with 100 here. Okay. Young's modulus would be surely given. Gigapascal is 10 to the 9. So now it's just a case of plugging in the numbers and calculating. And this is what you get for the force. If that's the force, mass is just divided by g. Well, it's about 6:30 and I'm still in class. I've done the quiz and I've now finished the problem set. Hope you make use of it. Good luck.